So the minimum deviation condition, which is very important condition, so I am making a full point on this, full lecture on this. So at minimum deviation, let me draw a prism now. So this is a prism. So at minimum deviation condition, what happened? The ray goes parallel to the base. The ray goes parallel to the base like this, right? So that means if I draw the normals, so these being the normal and these being the normal, right? So at that time the angle of incidence I and E will be equal. So at minimum deviation state, I is equal to E, right, and we denote the delta by delta m. Therefore, so delta equal to, we know what, I plus E minus A. Okay, also note R1 and R2 both will be same also. Delta equal to delta m, this is, and R1 equals to R2 equals to R, let's say. Okay, then delta m would be I plus I minus A. So this gives me delta m is equal to 2I minus A. So implies I equal to delta m plus A by 2, and from the expression of prism angle, A we know is equal to R1 plus R2, but both of them being equal, so we can write this as 2R, implies R is equal to A by 2. Therefore, now using Snell's law, you can use Snell's law. Let us use this Snell's law in this case. Using Snell's law, this is A, B. Using Snell's law, at the face AB, we can write sin I by sin R is equal to, now the refractive index of the prism material is N2 and the surrounding is N1. Therefore, it should be N2 by N1. Now, N1 being air, it will become then N2 only. Then, so we can write N equals to, so N will be equals to sine of I is how much? Delta m plus A, delta m plus A by 2 divided by sine of A by 2. This is the refractive index. This is the relation between refractive index, angle of minimum deviation, prism angle. Okay, so this one with this equation you will use to find out, you will have to perform one experiment in your course. There is one experiment in course where you have to find out the minimum deviation condition for a prism and then find the refractive index of the prism. So at that time you will have to employ this relation, and also using this relation you will have to also you will be able to plot the graph of the I versus delta versus I. Okay, so this is the minimum deviation condition, correct? Now, if I let us take one numerical on this to understand. If I give you, let us say I give an equilateral prism. Consider an equilateral prism. Consider an equilateral prism of refractive of prism angle 60 degree, okay, and refractive index n is equals to 1.5. Okay. Find the angular minimum deviation, find delta m. How will you do this? Very easy. You see, we know the relation now, n is equals to sine of n equals to 1.5, absolute refractance is 1.5, that means surrounding medium is air. So, sine of 60 plus delta m by sine of 60 by 2, that gives me sine of 60 plus delta m divided by, oh sorry, here is 2 divided by 2, then sine 30 degree, sine 30 degree is half. So, here it is 1 by 2. Now, refractive index 1 n equals to 1.5 means 3 by 2. So, let us write this here. So, 3 by 2 is equal to sine of, so here it would be 2 into sine of 60 plus delta m by 2, and then we can move further, we can proceed like this. So, 3 by 4 is equals to sine of 60 plus delta m by 2, right. So, then what we can do now? So, now, oh sorry, did I miss 3 by 2, 3 by 4, okay, no problem. So, now how much is this? Sine inverse 3 by 4 is equals to 60 plus delta m by 2. Now, this one will approximately come to 0. If I divide 3 by 4, it gives me 4.07, that gives me 72892 F575, 0.75. So, sine inverse 0.7, this gives me 0.75, sine inverse 0.75, right. So, if I look at the angle, it comes out to be 0.75, or this will be definitely provided. I am giving you the value now. So, it is 60 plus delta m by 2. So, I will give you the value, and this kind of a questions comes, this will be provided to you. Okay. So, I am giving you this value close to around 48 degree and 35 minute, okay, equals to 60 plus delta m by 2. Okay. So, now therefore, how much do you think it would be? So, delta m will be equal to 60 plus delta m will give me, if I multiply it, I should get 10, 6, 7, this one should give me around 48, and if I multiply it like this should give me around 97 degree and 10 minute. So, then delta m must be equals to 97 degree and 10 minute minus 60 degree, it should give me around close to 37 degree, because degree only can do. So, 37 degree 10 minute. So, this is the approximately 37 degree. So, delta m will be approximately equals to 37 degree is the, remember this, when you do the practical, your value should come close to this, that is 37 degree. So, delta m must be equals close to 37 degree. Understand? Okay, then, thank you.